So in the last session, we tried the class variable and object variable part. Right. So as from the today, before starting to class method, we have to understand the what is the key understanding behind the decorator. Okay. And for the decorator concept, we had to understand the key concept of the closure proper closure. And for the closure things, you have to understand what is called the higher order function. So let's start from one by one. First, we'll start from the higher order function. Can you please mute yourself? Thanks. So in the higher order function, if you go through, like I already opened that file on the Wikipedia at first class function. If you go, the definition written there, like in computer science, the first class function, it treats function as a first class citizens. Language support passing function as the argument. It's a hard, means yeah, it's really hard to understand what's there written by just reading through it if you don't know about the key concept. Yeah, but there is some key point like passing the function as the arguments, one thing. Okay, returning them as their values from the other functions. Okay, and assigning them to the variable or storing them in the data structure. Those are three things, remember. Means in first class function or the higher order function, we can simply say we can use function as a pass and an argument. We can use function as a stored as a variable. Okay, and maybe we can return one function. So we can use means we can keyword is a function we can use as an object there. So we can any kind of activities we can go through by using the function. That's why it's called a higher order function. Maybe in the modern language, program language, either it's called your Python or maybe in the JavaScript. Maybe such kind of modern programming language supports a higher order function. So just simply build through it. Let's create one simple one simple function. Okay, suppose maybe some squaring of a variable. If you get one, give one input like 2 or 3, it simply returns back your squaring element. Okay, like either 4 or 9. So create square, and there is as usual you can give one variable. So suppose x. What it will do, it will simply return back your squaring of that element. This way function already executed. Okay, now function is stored. Now, like what we did previously is we write square. Suppose value say we give the 5, you can execute and give the 5 value and it will get executed and gives the output the written by default. That much you must know. Now, if I write, say, suppose one variable f square. Now, if we enter f, simply nothing but 25 return. The function is behind is with capturing the variable f. What we are capturing? The returning value from the function. Okay. In that line, we are call that function. So passing one argument and returning whatever the statement is written. That's it. And the returning statement will be catching or maybe storing using one variable that's called f. That's what you know. Now, if we write like say f equal to simply nothing but square. Now, if we write like that, and then print f. If we print that element, you can see that is nothing but printing the function itself. As you can see that we are nothing but using our function in a new variable to represent the old function, right? We are using the square function here, and we use one variable, new f variable. So that f variable is nothing but representing the function already declared. That's square. Now if we write like say print f and 5, we are nothing but f represent our already the declared function square, and we are calling that function using that one argument 5. We execute simply nothing but it will return your value 25. So as the function is, if we check the like what is the memory location of these two, we will see that both two will be indicating the same things, the same element of the square function. So we are using one variable that is called f, using that variable to store the function we already defined square, and we can use in multiple, like say if we declare much another new variable, then it will definitely nothing but declaring the same. If you want to see like sometimes there is one special method called underscore name, and it will nothing but represent which function is defining from that variable. We go print say underscore name. Okay, then you can simply see that f is represent square. If we check that id of f and id of square, the both are the same. So both represent the same function. We are using nothing but one new variable to represent that the function you already defined. So that's why I told you that in the higher order function we can use, if we go to the like there is one argument like we can assigning them to variables or storing them in data structures. Okay. There is one thing is written as a some programming language series supports anonymous functions as well. Okay, we will know that part, but it's not much useful until and unless we using the encapsulation. That thing. Then that time we will using how we can make one function anonymous. So let's name this first class. Like the same things we the same concept we will know in our when we defining one variable, same kind of we can define variable and storing using that variable to represent any kind of data type, either it's a string or any kind of list or string dictionary, any kind of data type. The same key concept is behind each and every part of our Python, either it's a data type or it's a function. We can again using that variable to represent a function. Okay, that one. Now, why is that? Because same things. Sometimes say this is square. Sometimes suppose one of the great example will be our map function or maybe filter function. Those function you will see those function requires two argument. One is they require one argument as a function, and another argument will be some continuous data type or maybe some iterable data type. as you guys already know, like in map function, if I write say map and then suppose we give one function there, say where we are giving one function is square and one data type, say one list of data type I provided. Okay. And we executed that we know it's created one map object. Yes. Simply we can get that value of that map object, we can simply convert it the data type and we know the value of it. Okay. So map is a really good example of your higher order function where it's simply nothing but uses the function you defined, the square function you already defined here, and then the continuous data type. Any kind of data. We provide a list and it will nothing but it will iterate through each and every object and return from the functionalities we already defined, either it's a square or cube. Yeah. So map function is a really good example of a higher order function or first function where we can pass function as an argument, okay, and then the next argument as an array. So the it's satisfied the second properties of a higher order function where we can pass a function as an argument. Okay. If we want to debug, maybe say suppose we want to see how we can pass through a function. So we know that this is a square function. Let's create our map function properties. Suppose def my map, and we can give is as argument, say one function we can give and one array we can give. Okay. Now for there, say the array will be passing for I in array, create one new variable here, say results equal to an empty list. Here we can write like some value will be returning from that. So value equal to, we are calling that function with I, that argument, and we can append that value. Value dot not the value therapy, sorry, value we can pass, the result we had to append there. Results here we appending using that value. Then after finalizing the loop, we will return our results. Execute. No error is there. Now you can simply write, say suppose we want to use one variable, say squares. Okay, squares to defining our maybe the new variable to storing that the function you given, say my map. Okay. Now suppose we can pass like this is our new variable that defining our function squares, and we can passing argument as a function, say one argument is our square, okay, means that one, this part, and another is our array. Okay. Okay. Now let's debug that. First this list and this square will pass through, it will came here my map function and array. Correct. Now we are defining one easy and simple empty list variable to capture whatever we returning from that function, we calling inside that function. We are passing one loop to access to each and every element Yes, that's why for I in array, now it will take one by one from each and every element inside that list. We are using that one local variable to capturing that value is returning from calling that our square function, because it func is represent whatever function will be passing through. Here we will be passing square, so it will nothing but returning from that square function. Okay, so we are passing through each and every element, so either it's starting from one, because it's from one loop it will take one value, and the results, as we are defined the result is an empty loop, so results will append that value to an empty loop. Okay, and we are simply nothing but returning the results. Execute that, you can see the value is printed. Okay, so this is how behind that time when we discussed that the map function, we didn't cover that part because it's required this concept, the higher order part. I don't know if the I already said or not. I don't remember, but mostly that time I only told you the only the map function, or maybe the filter function, or apply map, those function, how those what is the key principle of this functionalities, what is the concept behind those function, I didn't cover that time, because now you can see how all those built-in things works in behind. Either say suppose there is called cube, if you want to the value returned as a cube, you can simply return as a cube dot x and return x into x. Okay, now you will simply return your cubic root value, and now the same function, nothing but it will allow it. Same things if we write say squares, because squares the variable represents our function. Okay, maybe we can give it the square root or cubic root, whichever name it will be suitable for you, and then pass our function. Say cube. Okay, and this array, or maybe list. Hmm. Now you can see is simply nothing but returning the uh, cubic root of each and every element that present in our array. Okay, so we already used a variable to store our function. Okay. We passed one function inside. If we pass one function, they're already defined, declared or defined. And one more thing we can see that we already called the function inside a function. Okay. We called a function that already declared or defined in a global part. Okay, not in the inclusive part. In the global part, we declare. And you already know, based on our AGB rules, we can easily call that global variable or global things in each and every inclusion part inside our program. Okay. If you see one example, I can another example is so that how much time. So suppose you want to print one message some times defined, like you want to print 10 times of a message. Maybe you want to print two times of a message. So you can create one function, and then in function you can create like say something one message in one function. In another function you can create some kind of loops you want to print. Okay, now we can pass through each and every from that part. Say let's suppose declare one function, so that was welcome. Okay, I'm keeping it simple, so nothing pass from here and something printing statement. Say so much. Okay. Some printing statement. Now another function we print says how many time we want to print, and here we'll be passing through two things. One is the function we already want to execute it, that's using that argument, and maybe let's keep it different name here. And another will be the times, how many times you want to print. Now if there's two things you can think, one is simply nothing but we can create one loop or maybe one function here using that loop. They are simply nothing but we can use the recursion part. Okay, simply nothing but increase the time. And if in the recursion part, if you know that when recursion thing is started with a negative integer or maybe zero value, then it's simply nothing but there's some kind of default statement you have to state it. Okay. If you know that factorial for factorial 4, the example I already told you about, then there when the integer starts with 0 and negative, it will simply nothing but return you 0. Okay. So we can simply write using one if else statement. Say if our times is suppose less than equal to 0, then will be something like return none. Okay, we do not have to return anything else. Say we want to call that function, that is our f. We call that function, so it will nothing but returning that print statement. And as we are calling that function, if there is times we provided like suppose like no condition, if I provide here you can see, then there will be it might go out into an infinity loop. Okay, so I definitely had to write one condition, so there is some a decreasing value. So we are calling that welcome function inside our loop, and let's call a recursion. Let's take one recursion part. Okay, the recursion will be calling that function, the same function we already defined, loop, and we will be calling using one argument is f, that function, and another argument will be if there will be 5 times, so it will goes into it, say one decreasing in order, say time minus yes, no error came. Now you can simply write say loop and say our welcome, and suppose time is going to like, you can see it will when we create one object or maybe one function element, we can calling that function but using the basic recursion principality, we are decreasing that value, so it will only return you 5 times. Okay, so we are using one recursion function where we are passing one another function as an argument and simply print through it. Okay, so as because you can notice one thing, that how or why in general we can easily pass a function. Okay. Because in our higher order principality, it follows like each and every variable, either that an argument or parameter. Because when we are passing that function welcome here or maybe square here, that passing function is nothing but passing as an argument. So when we're passing that argument, we are using another local parameter to represent that function inside of our enclosure. So if this properties is that property isn't supported, then these things also isn't supported, isn't it? Say this square function, we are using that variable to represent that original function, or maybe when we inside that function, we are using that argument, okay, or maybe that parameter welcome. This is our exactly function. As I'm not creating any new variable or new things, you can simply using that function already defined, that welcome. But the thing is, this argument we already passing in that local enclosure, it represent using that argument. If isn't supported, like describing with a new variable to represent our already defined function, then it will not be not supported to our higher order bits variety. So that's why in Python or maybe in JavaScript or maybe in other languages, in higher order function, it told when we can use a function as an argument, we can use a function, we can use a variable to store our function in an entire data structure, or maybe we can return one function. So that time we can easily call this as a first class function. Okay. Now let's see how a returning function works. Okay. Say simply if we create one logger file. Okay.
Hello, sir.
Yeah.
Sir, can we write like times less than equals to zero, then break? Can we write this?
Time less than equal to 0, then break. Yeah, you can write also, because if you write like time less than equal to 0 is nothing but that time the entire loop is break. Let's see. You can see.
Mm,
You can tell me like why this error is came.
syntax error.
Because yes, because it came like when we write break here, that time first it will start running, say loop, as we already defining one recursion part, so it's nothing but it goes into an infinite loop. Okay.
Mm,
So when we write like those types of concept, that time that break is situated as your first principality, means it will start to read the first before starting of a loop. So that's why it expect your argument as before getting the break statement after proceeding into that loop part. Okay. So for the as for the first when we pass that argument, okay, it may not read here. Okay, it before passing, when we store that value, this concept, we can see that the loop part is start here. Okay, the loop part is started because we are running recursion, correct? But when we defining the break statement in that if part, that's why it gives you a syntax error, like the break you already written in outside of your loop. Clear?
yeah.
So that's why, but those are experimental, as I told you. Like more experiment you go do with programming, the more the concept will be clear to you. That's a simply new thing. Even I didn't know that the break this syntax error it will came. Okay, that's why told you, as you told me, I experiment. Okay. So as the break statement you already written here. So in Python concept, when you go through line by line coding, reading of the line by line to the your machine coding, machine diverted coding part. That time, first Python tries to find that break statement before executing a loop part, not that one, this line. So
Sir,
definitely it
what
will.
happens?
So
Sir, what
definitely
happens?
something like you will written as a for in some say say some string and some statement, and this is nothing but reading as like that. Okay, you get that point.
Yes, sir.
That's why it gives you a syntax error. Because by reading we are not executing, not came into that part. When we read store that function, that reading of that function, you get that error. Clear? If we like use, you can also use like say suppose, hmm,
If we write the break statement in the else part, then
we did not need to write the break statement in the recursion, because the condition is already given.
yeah, yeah, yeah.
This is a condition. That's why we need the, because it will not starting the loop. It will not even let start the, definitely some error will come if we write the break statement. Because break only we will use in general. If we ask the conceptualize, then there will be some condition is satisfied, then only it will break. Okay. Inside a loop, because it break or the continue part in general used inside our loop when some condition is satisfied. Like as in the example we already seen, like some value service, I see if some value is equal to 5 or any other kind of, then it will break through the entire loop from that particular point. Okay, that is the purpose of using break statement. If we are not have that clear logic of using that, when in a loop we need to break that part, then definitely we have to build like other kind of logic. Okay, but yeah, definitely it's a good thing that you find out, you try to experiment those kind of things. As I already always to, like from the first session I already told you that more experiment you guys will do, the more will you will guys learn. Okay, like in the same things, if I, let's do one thing now. Suppose we want to return that. Okay, we want to return a function. Okay, let's remove that part. No, let's create new function. Suppose in logger file, sometimes software developers people easily says that a logger file where in the some statistic already printed or get stored inside our backend of our coding. Something some coding we are here to do. and some statistic it will be stored in our logger file. So if I simply create one logger file where we will be printing one message, say logger and some message, and inside that part you will create one. And now print statement. Now returning our now look closely. We are defining one function. Inside one function, we define in the local scope and some print statement. Then we returning which function. So thing is when we call one from the first function here, the logger part, it will simply not return that the inner function, the log message. Okay. And the returning value, maybe we use some new kind of variable. If we call using that variable, that time the inner things will work. Okay. Now say suppose we are simply nothing but printing hi, log hi equal to our function logger and say some message. Execute that. Now what the logger high is represent, if we print that sorry log high their function, you can simply see that log high is now represent inside that logger function. Inside that logger function there is one local things. The local thing is log message. Inside that enclosure logger, the local part is a log message. That part is in means represent. Okay. So you can simply check using by the special method using the underscore name. Okay. The thing is inside our enclosure there's a logger, there is the local part is the log message, that thing is represent using that variable log I. If we check say log I dot, okay, now you can see this variable represents that function we already defined. Okay. So we are returning one function, we are returning that function when we called that function logger. So as we before, we already using one variable, we simply pass and function as an argument. Now we can return our function as a result. Okay. If we run that part, right? So what will we that will do? Will come again because this part will start our concept of closure. So if we start, if we execute that statement, then simply nothing but it will you will nothing but call that function, okay, as it represents that local inner function, and print that statement, print some log and some message. Execute, the message will be printed. There will be one really good example that's I want to give you. The good example is sometimes in your web part, if I want to develop a website or any web application using Python, Django, or Flask, that time sometimes you have to dynamically send or inject some HTML template Okay, using those modules. So using this higher order function is used there. How you can pass through each and every variable, each and every function there from that function it is. So if we create one function like a say HTML, it's a function, and inside that we want one after the tag bar there will be some say some paragraph, okay, or maybe some chunk we want to print within the tag. So some wrapper we need to need, some wrapper we need to need, and then our print statement. So this is our statement, and we will when we execute we'll simply return our local. Okay. Hmm. So our HTML tag, then our text will be printed and we return that. Now let's write something. Say in our there will be in the HTML tag will be simply sending some tag values. Either it's an paragraph tag or heading tag. Okay, and this is the text will be simply nothing but sending some messages. Yeah. Now print one statement. Say some yes. Say some tag will be there. So 0, then this will be considered as a 1, and this will be considered as a 0, then dot or format, and the value will be tagged, and then our message. Okay. Let's make it more realistic. Uh, Give it fine. Now, as our function is already defined, let's create one variable. Say print our first line. Say maybe we'll be printing one heading element. Okay, so let's call our first function. That's an HTML tag. Okay, HTML tag, and we'll be giving one which will be tag we want to pass. Either it's a paragraph tag, maybe one heading tag. Okay, maybe one table element. So we want to print simply nothing but one heading element. So let's write H1 as H1 represented heading one in HTML. If you guys know. Okay. Now say some printing statement. Say our printing statement. Say print our H1. Simply nothing but call that H1 and call it using because H1 is represent our that function the wrap text, and wrap text needs one message argument. Okay, so message will print that tag we already passed through. The message you need to print. Say this is called our head. Okay, execute. You can see we get it as our HTML format. Okay, the headline of that element. So in a real example, like sometimes we had to change those things. Maybe like good example is our newspaper. in the newspaper, maybe some page, some editorial page where the tag is fixed. Either it's an some portions of tag, no, some functionalities is fixed. I will say some tag. Maybe you need to bold one line. From tomorrow newspaper, you want to print one block of new message. So the headline will change, the message part will change, but the functionalities of the editor part, functionalities means maybe it will came like in third page or maybe the fourth page. Maybe third page is fixed. If we go through the Times of India, the those kind of newspaper, there you will see there is called the editorial part. Either it's on fourth page or the third page, the top left corner, the functionalities is fixed. So for those functionalities, we created these things. Okay. Now as a tomorrow for the tomorrow's newspaper, we want to create the new headline, the new text messages. So for that time, we want to create the new headline there and maybe some new editorial text messages, so that will be printed for tomorrow newspaper. So you only need to change only the headline and the text message, but the other functionalities is already there. So definitely you can use one dynamically template, and you can only pass that entire text or the you need to print or you need to show, but the more or less the each and everything will be there. So you did not have to modify the entire HTML template. You can simply use the dynamically template to pass through only those things. Yeah, if I cover the basic Django template, that time you will see how we can nothing but simply how dynamically pass through each and every template. Okay, using the HTML tag or HTML template. Okay. Now come back here. This is how. Suppose we want to print one paragraph. We can simply write like say P1 and our HTML tag. And now we are using our paragraph tag. Okay. And let's call P1 and see our today's. Okay. Now execute. We already the get one headline and a paragraph for today's newspaper, and we can simply send it to our HTML template. You will know that after the HTML template, it is nothing but treated as our headline and treated as our text paragraph. Okay, so that's how you can, in the reality or the near reality, how the Python is allowed your higher order function properties to use those templates. Okay, this completes our higher order concept. Okay. Now we'll start our the closing properties. So the closing part is that, as I told you, we already come back in here. Let's create new variable. Okay. Let's headline our closer is new value. Suppose since the already one example I gave you when we'll give you the example of our the basic local inclusion global and built-in properties. So create the same similar type of example. Say this is our outer function. Inside that, this is our inner function and some print message. Say print message. Now, in the closure part, closure means if we go through our the formal definition, that time there is so many things like also lexical closure is a technique for implementing it's an hard things to understand by just reading through those lines. Okay, but one thing you can see that a closure is a record storing function together with an environment. Disable means closure nothing but sometimes you may, if I give you the example, sometimes you may execute that function, but some functionalities, some properties maybe can used inside that local. Okay. Say if I write like def print and that part we know. If we write like here a, we already get the name error because in our properties after executing that function and only that variable is the bound to that local property. So we are not means we cannot use this as a global variable. As that part we know. But one thing is that after finishing that property, because the function already executed, then after that nothing we generally know that nothing we can use in our global stage from that functionalities here. If it's maybe sometimes some integration or some square value we need to print, the functionalities we cannot use, even those things will be executed. Okay. Because that's the properties are eligible. We cannot use each and everything after that function is executed as beyond its local scope. Okay. Now this is one thing. Here we will be creating one messages as outer. Now after if we like execute that function, that the outer function here, what a message it will do. Okay, if we give this full message, do nothing but printing your message because the outer is nothing but executing one thing, that inner, and it will be printed. See, it will be printed. What I try to say is, say, come back to here, or maybe create one new, say, create one new properties, new example. Because for now, we can see that when we call that outer function, it came into that line where we'll be capturing that value will be the inner function and we're reading it. But the inner function is using that variable call message as the message is not a local variable here. Message is called is enclosing part of that outer function. So it can use each and every part of that functionality. Okay, and only this function is empty. Now the same if we write say suppose message equal to some message where we change our variable. Okay, now in our statement let's print welcome at our now we'll see, say suppose create one variable and write like say outer and say job. Okay. Now if we execute, you can notice print say suppose say, let's check which things is represent. Now notice one thing, when we executed that part, that line, nothing but we are executing that outer function in a message. So this will came here as a passing argument. Now the message will be bounded to that enclose. So it will be using new variable to represent that message. Okay. Now after that, as it's definitely not coming to our part, because this thing is only depending on function instead of that function. If we not like calling that function here, so it will not doing anything, but simply but returning that function, that inner function. So notice one thing, when we return that one inner function, that time the function is already ended. When we executed the outer function, this outer function is already ended here. Okay, after call that thing. So you may raise one question like the outer function, when you call that, the outer function is already ended. Why the inside of that thing, inside of that function, we can't use? Because in our properties, in our basic to our common sense or the common knowledge, whatever things will be executing inside that function, after that things we may not use that part, either it's a variable or function or each and everything. But here it basically closure allow us to, like, whatever things will be bound to that environment, we can simply at that point we can simply treat as its own environment. Then it will whatever like function or the environment it will be provided, it will go bound to that. But first it will simply treat it inside the local environment. Okay, so say suppose uh, now when we call that function, okay, so when we call here, it will nothing but for a minute the closure allow us, like, for a second store this function, for a second store that function, and when we execute that function using that variable hello, so it will printed not only the means, it will not only executed that print statement, also use that message variable that we are defining up in outer, means as a local, this is sorry, as a enclosing variable used inside that function as a local variable. So after finished executing that the outer function, we can simply use that inner function using that variable hello. This is basically the closure property allow us. Okay, because if we see, as I told you, a closure is a record storing of a function together with an environment. So within that environment, either it's a mapping associated with the free variable of the function or maybe value or reference, as I told you, but the name was bound, the closure is created. So when the closure we will be creating, enclosing that what the closure is creating, even after executing that the outer function or everything, maybe some clue will be there. Okay, like using that a hello variable, here, some clue will be there. Using that clue, we can again or maybe rebound much more time, or maybe infinity time, we can execute the inner function or maybe the closure properties. Okay, this is one again one principality of a higher order function. Okay, so as the higher order function allow us to use that function as it's the closure properties, so it can definitely like access or maybe use the advantage of her closure properties, so that as many times we need to use that enclosing or maybe the storing procedure or maybe the enclosing procedure as many times in our programs. Okay, so once again we are defining that example, we are defining one function, but when we executed that function here, so it may stop. As for our normal logic, it should stop here, so maybe some value whatever value this thing will be stopped here. The next thing is whatever the next principality we try to do, that time it may not get gives us as a desired result. Okay, but in the closure it's nothing but stored for a particular point, and using that basic logic we can again like re-execute that the inner part or maybe use that values. So for a second this message used as a local variable using that inner function. Okay, and maybe whatever bound it will be there apart from that function, maybe some global variable we can use, that mean that is their thing, like which function is user, but within that enclosing space it must act as that local part. Okay, so local part, it will be stored that value, then it will be executed. Let's see another more variable. Okay, say write one thing, say nothing. Okay. Now say simply print here message one. Okay, and give one argument is message two. Mhm. Say this is our message one. Give a new line space. Not return. Okay. So when you executed that part, we're passing one variable John. So outer function will be executed, and then it will goes back, means the hello will be redirecting to our inner part. Okay, so but the variable John, as there is no nothing things will be there, we can simply write you we can simply writing here the variable inside our local scope. Okay, but when we pass through the after we executing that value, the local scope value will remember which value will be passing when we will execute it. Now you can see it's represented in a, let's print it out, say maybe some other, say suppose hello and say goodbye. Okay, using another variable, which is variable does, for that variable we will be using our inner function that's called inner or maybe called hello, because hello is represented our inner function. Okay, and give one values here, say goodbye. You can see when we executed, because that part, the outer function is already executed. But for that point of manner, the variable value, that is the message one. What is called? That is John. It remembers closure properties in the function, Python function or maybe other function properties. It remembers for that point of seconds. When we we only execute the inner function inside of this outer function, it definitely remembers that variable or the whatever argument we will be passing through. Okay, so that's why it's printed that statement. Otherwise, you definitely see some errors. So this is the basic properties of our closure. Okay, maybe some other definition you can follow. Say closure. You can see other definition like a function defined inside another function is called a nested function. As we already did, the nested function can access variable of that enclosing scope. Okay, so this is our closure function where there is one good the value in the enclosing scope is remembered. The value is the enclosing scope is remembered even when the variable goes out of the scope or the function itself, or maybe removed even the current namespace. Okay, so after we executed, definitely there no logic behind to remember that part because you already executed that function. But that variable the in closure properties is remembers for that point of second whatever things will be passing through the variable or maybe each kind of thing within the local scope. This only works in our local scope. If we try, as I says to, when I try to execute one variable outside that scope, then there will be no issue. If I here write message one, definitely there is one error because it is not defined. So it will only work inside your local scope. Okay. I guess clear. What is the
Sir,
hmm.
so what is actually outer function returning? The inner function object?
For current now, let's forget about returning part. Okay. For a second, just consider when we call that outer function, whatever things it will return after executing that part means that function is already executed. Correct.
Hmm.
What are things will be written there? The function is already executed. So if we executed one function, then for that point of things, some variables or some things we may not use. Say suppose let's in the built-in function, whatever we will do like length of one string. Okay, length of a string. It will simply return your string values. Okay, after that, whatever things will be written inside the length function, you can't use. Okay, so this is one thing. The next thing is come. Suppose when we call that outer function, it will simply return your inner function. Okay, the inner part is returned there. You call that inner function, some principalities will, some like functionalities there that will be present and it will be executed. Now the thing is, when we call that inner function, there is one variable called message one. So this is one argument. that we are using when the outer function is called. It's called way before, like here. It's called way before, but it still remembers that variable when it passed through. Okay, when it's passed through here. Clear. So the variable is still written. Otherwise, there should be no message or nothing will be printed. Okay. Even though the inner part will be executed, the inner function will be executed, then only that part, maybe only the that part is executed because you only using that this argument message to, and this is our message to. So only the goodbye statement should be printed, the one thing, but it still allows to use that the enclosing variable that already defined or already executed when we call that outer one. Okay, so when we call that outer function, that time here, because as a simple language, as I told you, when we work in a real life, it's not that simple. So for that point of matter, it's definitely remembers within that scope. Okay, that's why it's called an enclosure. So within that scope, the functionalities it already remember, but outside that scope, if there is some other thing, maybe some return, some return, if you write like return none, okay, then if we try to execute that inner thing, maybe the or the message too, then definitely it will not be executed. Okay.
But sir, can we write? I mean, can we call the inner function besides the return? I mean, can we write like that?
Can you call that inner function? Yes, we can call, like, if we not returning anything. Okay, my you are not catching my point of view. My point of view is,
I'm saying, can we write? I mean, I'm saying, can we call the inner function besides the return statement? I'm saying that.
I understand, but
I'm
this
just
is not
asking.
my point of view is, whatever you try to do within that scope, it can accessible. If we executed inner function, say suppose let execute inner function. Okay, so when it come here outer, it will execute here the inner function. When you call that outer, it will execute here. Now when the inner function is executed, as we are not returning anything, the inner function is executing, so it will comes again here in that inner function. It will try to find first message one will be printed, because we will be giving one message one value, but the message two value will not be printed because let's uh, now call that, you can see simply call the type error, because as message one will be printed, no issues, but the when it's try to message to the John, then that time it will not pass, we're not passing any argument, correct? So definitely
And
you will show the error.
if we write return before the inner, then
If we write before the inner, if we
if
write
it
before the return, before the inner, so return will nothing but it will simply return you the executed value of the inner function. So executed value is definitely needs one argument here.
yes.
Are you
So what?
passing that argument? No, because you are only passing that argument here, the message one. Same things will happen. Let's check. You can see same thing will happen.
And if we pass that argument there,
If I pass here,
yeah,
you can write anything. Say by definitely when we return that argument, returning that function execution with an argument of by, definitely there should not be no error. Okay, the error is come because here.
Okay.
If we write, correct.
Mm.
So this is not the things I'm trying to tell you. Like the variable, whatever you will try to do within that enclosing part, the function will remember. Okay. So maybe how many times? Let's give you one new example. Let's clear it here. Let's return. I did one mistake. Okay. Say let's give you one good example. Okay. Suppose we want to find out summation of the multiple argument we pass. We may not know how many argument we are passing. Maybe there are multiple number of integer number sample, maybe multiple number integer list, or maybe other format. So let's define some arbitrary number of argument we will be passing as an integer, and it will gives you nothing but summation of it. So one function defined. Now we'll definitely from that closure properties, we are step by step we'll be moving into a decorator. Okay, so we can wrap up one function inside others, because these things, passing function as an argument, returning function as an argument, this is the main key concept behind our decorator. Decorator is nothing but, if it simply goes through the by the name, then it's decorator. If I call you that, what comes first in your mind? Like some things is wrapped within it. If we give you example as a present, then the present is wrapped within some decoration, maybe some special kind of clothes, or maybe some special kind of wrapper it used, but it will wrap to provide the decoration. So something is already bound to that particular one. Okay, if you choose one gift, then gift is completely bind to a wrapper thing. So we call it as a decoration, or maybe the decorated element. So decorator is nothing but when one function, maybe one functionality is wrapped within that function, or maybe class, because we jumping from the function to class. That's why I call it class. So that time we simply use the decorator. This is called the decorator. Okay. So if we, as for the simple time, before jumping into the decorating part, let's create one function. So inside that function, we can call one another function that's bound for globally. Okay, and we definitely see our closure properties, how closure properties works much betterly. Okay, so we will be creating one function that is called summation to sum up our value, and say for that time pass, and we'll be creating another function. So as you can see, it shows as your green color means there is the sum is in a built-in function. So better we should not modify this one since the name. Okay. there is another function, and set that function, say as e written as your inner and as till that much we know, means if we only consider we already did that thing, like whatever when we return that inner function, return that element with that enclosure, we can use that each and either it's a variable is defined or each and everything is defined. Now using that closure properties, we are using the higher order function to pass or maybe call or maybe return that another function. Okay, say we are creating the summation part, whatever the element will be passing, either it's an array type or maybe each type. So as we may not know that how many element it will through, either we will be creating 2 values, 3 values, 4 values, we don't know how many integer we will do. So in Python, you guys already know we can use that. For arbitrary argument we can simply use star args. Okay, so it does not need to define how many arbitrary argument we will be passing. We can simply reflect it through this star args. Okay, right, star args here, and then we can create one logic, say for I in args and maybe some summation value. Okay, summation value equal to plus equal to 1, we can write like that, plus equal to I, so it will sum up, and then after finishing that loop we can return our summation. Create one empty variable, summation is 0. Okay, so our summation part is worked. If we check like sum of 100, 200, 300, this part is worked. Now let's create and pass one function here, say f, to represent that function. Within that inner function we can simply pass, like what I'm trying to do is I'm using that function to call or whatever things will be there in that function. So we are passing one argument as a function here, and when we call that function, it will simply nothing but return our inner function. Okay, so when we call that inner function is nothing but it will return executing that properties. So inside that inner part we can simply write, say print our executing of that function, f function. Now as we try to pass using that argument, f is that summation. So let's define add is equal to some, say a function, and this is a function name, right? This is a function name. Now there's one thing, if we go to step by step, let's check first. When we execute that function, pop function, that pop function will take one argument, this is f. So and it will return our inner function that is here. But when we call that inner function, it will we definitely uh, executing whatever function will passing through that f argument. So passing through this f argument is a summation function. That's what I'm trying to do here. So summation function is arbitrary argument as how many types of argument. So definitely we had to write some arbitrary arguments. So it will, if we don't write, then there will be some error. In my logic, there should be some error. Execute, and as now print, it's represent our inner function. Okay. Now if we do anything using that inner function, say 100, 200, 300, it definitely throws some error. Yes, it's definitely throws some error. So not the inner, the add. It's definitely throws that error. The 3 was given, the 3 argument is given, and no one 0 is defined. So definitely we have to pass one argument here, the arbitrary args, and we are calling. Now we execute. Yes, you can see if we goes into a little much deeper, then we defined one function. That's not a problem. Came to here. We're creating one outer function. Within that, we're creating one inner function where we're passing function as an argument. We're passing here function as an argument, and within the inner function, we nothing but calling whatever function will be passing. So as we passed one function that takes arbitrary arguments, so we definitely had to pass through the multiple arbitrary arguments. We definitely, when we call that using the function, it definitely has to call the arbitrary arguments. So that part, whatever things it will be returning here, summation, it will simply print it. So first, when we call that function, the outer function using the function as an argument, the function this one as argument. So this part is defined. Okay, it comes here. It will returning our inner function. So add will nothing but represent our inner function. Correct. Then the inner part simply requires some arguments. Some arguments, as it will definitely, when we execute that inner function, it will execute the function f. F is represented as summation function. So the arbitrary argument is passed, and the thing is the summation value is returned. So it will print the exact summation value. Okay. So when you execute, first we want to check this add will represent the inner function, and then within that inner function we are passing function as an argument, so it will be returned. So my point of view is, we when we when we passed the two point of view, one point of view is that argument, if argument, we are using the higher order properties to represent one variable to a function. That's why we can pass the function as an argument, otherwise we can do. Then as after executing that value, executing that thing, that pop function, then based on this, if we executed pop things, then this function is ended. So when whatever things will be there, some as because we know that the variable is only work when this function is still working, but because after the function ended, there is no such kind of things in this local one. But as closure properties remembers for a particular moment that exact stored that a variable, maybe other properties, so we can use that advantage. So we can, whatever passing through that value, even after executing that pop, then when we again re-execute the inner side, then These properties is the properties that function as an argument we can use and we can pass through. Okay, this is called closure. I guess now you are clear. Because these things, if you're a software developer, these things, if you create one logger file, that time it definitely you had to create one logger file beside your one. So if I create one logger file, say suppose the we are doing the addition or the subtraction of it. Okay. So this is our logger file. Okay, and inside that we're creating one function, the log function, where we can simply nothing but let's create our logic first, then we will check our argument. Okay. So inside that the log function, we can definitely check. We can let's create one info. Okay. So in Python, there is one module called login. You do not have to, like, I'm giving one example. That's why I'm telling those things about. You do not have to go through this thing by like end to end by yourself. Okay, this is just nothing but an example. So in Python, there is one module called, if I remember, mm, logging. Import logging and can create even basic config. Create one basic config where give one file name, say something like example.log, and for that time we had to provide one label. We are doing logging info. Logging. Now create one logger file. Okay, in that logger, as the same things, the same thing we did here, the same thing we'll do here. We'll simply passing our function. Okay, and inside the log function, we can simply pass the arbitrary argument. The same things we did, and then say we create our logging info. Say our running uh, run what time. Say we our arguments and that in the bracket. What is our function? The function will be providing Am I audible? Because the power cut happened.
Yes, sir.
Yes, sir.
Okay. So, so you guys seeing my screen, na? There is no.
Yes, sir.
Okay. So as we are creating that logger file, let's create a statement like we run that function with that argument. So this is our function and our argument args. Clear? The login. Now let's print, because we will be the same things. The same thing we'll be doing. We'll be here printing the statement like we did addition here. We'll be printing something called our executing our function using that arguments. Clear? And then we will return our log function. The function is created. Now we can simply create two functions like say addition and the subtraction. Okay. In addition part, we can do like y, where return value is x plus y. In the subtraction, we can do like minus y, x comma y. We return minus y. Yeah, those two functions we did. Now the same things. Let's create that variable to represent that function, like what we do, and pass that function here. Say we're doing the uh, addition value to our logger file. So call our logger function in the argument pass as our function. Then another function is subtraction. Give you the same kind of logically name. So subtraction. So now we call that function. It will return our log function. So we are now storing, means this example log, going to store that value, that statement. So for the statement and for passing like some argument we need, maybe as you can see there is only we are using x and y. We can simply write also like this function. It will goes a little bit complicated. So simply write the add one. Okay. Let's simply we are passing two argument. So we don't have to like concern about how many argument we will be passing, because we are using as the arbitrary arguments as a parameter there. Okay. Now if we write add our file, say something like 5,4. Okay, and maybe some login files, say 4. So when we call that value, this function will nothing but the returning value of our logger function. So logger function is log func. Log func has that argument, the arbitrary argument. It will execute it the outside of that function. That is the function. So this function needs two arguments. Two argument is given, so no issues. Even subtraction is two argument is needed. So two argument is given, and it will simply in our info printed that statement with our function name, okay, and the arguments will be passing. Let's execute. You can see like if we ignore that thing, for 1 minute, you can simply see we are adding those two things, x plus y, and get that value. Okay, using when we are calling that using that function, that logger function. And as we are also creating one log file behind the back, so let's check our log file first. What's my working directory currently? This is my current working directory. Go. You can see the info we try to print. Okay, you can see that the info is running add function, because we are giving the format function name with the arguments we are passing. Clear? So we created one log file based on whatever things we are doing here. So that's one really good example of creating the log file. Okay. Basically, as continuing our the current work. Okay, I guess that thing is clear, closer. So the same thing like sending function, returning function, the same things is with the base thing like return and send function is our key concept of our decorator. Okay. Do you guys have any question till now? So we will like proceed into our decorator function.
So just one thing about that logging part. What you did there?
Alright. This thing is not important. I am giving you the example, the same things I did here. Okay, the same things I did here. We created one
Yeah,
function.
I understand. I'm just asking what you
Uh,
did.
the log thing is sometimes when you work in a real project, you may had to create one. Not you, the software developer peoples had to create one log file like whatever things he will be doing in the day. So maybe that times he had to create one log file. Maybe he represent it to a manager, maybe something to save in his to-do list. Okay. So that's why I created one logged file, like simple nothing but kind of document file or text file, where using that the logging function. Already the module is presented in inside our Python system. If not presented, then you can pip install that. And using that logging.basic config is nothing but we created one file that is called example.log. And the things we'll be presenting is our info file. So that's why the document is written as info colon root colon then our text. Okay, these things will be written. This is a means nothing but the memorized part of your code. So
It's creating a text file.
it's creating a text file kind of text file, not text file. It's a log file.
Okay.
Okay, inside that log file, we are writing some messages like whatever we are doing. So here inside our log function, there is one thing is we are writing one statement. So we stored that value inside a log function. So good thing is means why this is a real life example. We can simply write addition and subtraction. Whatever we do is we're simply doing the addition and subtraction, but also we stored and message in our log file. So that's why we are not simply call our addition file or subtraction file. We are calling our logger function. So it will not only store that argument, that one principalities we written, and also print the statements we need to print, like the simple addition file or the subtraction file. Okay, this is basically need of the logging file. There is one we'll also repeat in the decoder part, like how we can create one log file, but it will be really big heavy for like first time to understand each and every one. So this is for my example. That's why I'm doing. Do not have to go too much deeper. When you had to take time for that. Okay. So apart from it, the main point of view, I guess you already cleared, like how we can passing a function as an argument, returning function as an returning function, and sometimes some variable to represent that function, and also some closure properties that Python may use. Maybe we don't know because when we try to debunking the concept, that time we understand. Okay, clear, I guess. I guess clear for that part. Then just give me 2 minutes. I am getting one call. Okay, I will then we'll start the take whatever. Okay, just give me 1 minute.
Sir, your mic is off.
Oh, thanks. So now we'll start talking about the decorator. Decorator is nothing but, as I told you, if we goes through like the definition already written in the books on the other part, then it will be much different. But for as a logical sense, you can think it nothing but wrapped up some functionalities to the function you originally defined. That is nothing but your decorator. So sometimes you may have to define some kind of functionalities like the things you already did. Okay, these things is already did. We already nothing but debugging the concept of the decorator more than 60 to 70%. Okay, the same things we can write using the simply using the keyword that the decorator or maybe wrapping the decorator as that the function. You simply write with it. But the key concept is we can pass the function as an argument, and then we can call that function inside in another function. Okay, that's why you can call as a decorator. So let's write one simple example. So let's write one simple decorator function. Okay, say creating our decorator, creating our decorator function. Okay, and pass our original function. This is our decorator function. and her original function. Say, suppose we are printing out some statement. Okay, some display element, or you can say simply like display. And say print original function display. This is our original function, and we are wrapping up some like decoration or maybe wrapping up that function inside in another function. Okay, this is nothing but call our decorator. This is our decorator function. Now inside that, as an decorator is nothing but creating one wrapping element, so we can create that thing, say our wrapper part, or maybe wrapping element, or maybe wrapper function, whatever name you want to try to do. I simply add the wrapper function. Okay. And this is simply nothing but return our original function. That's pass. Okay. Nothing but return our original function. And lastly, returning our wrapper function here. Okay. The same things we did till now, like this line or this line or this line. The same things we are repeating here. The original function, this original function will be executed inside our decorator function within some wrapping element. Okay. Now, if we print like we are calling decorator function inside the original function is display, and this function is passed through using some say like decorator display, decorative display. So the same things like we did till now, we are calling that function in we are executing our original decorator function while passing display function as an argument. Okay, no error is there. If you want to check what this keyword is mentioning, this is simply nothing but the name keyword. You can see it's simply nothing but returning your wrapper function. Okay, so if we call that function decorated display, yes, we call that part. So when we call that part, it nothing but executing our wrapper function. Wrapper function, what we will do, it will returning our original function execution. So our original message is printed. Okay, exact same things that we did before. We are doing the similar things. Okay, we're nothing but passing one function as an argument inside one enclosure, or maybe say nested function. Okay, or maybe closure function. Okay, we are using the advantages of our closure properties. What is the advantage? Remembering the argument after the function is already executed. Okay, the closure properties you already use, the advantage the advantage already used, and the higher order function properties already used that pass function as an argument. Nothing like no rocket science till now. Now let's make it more visual. Say print one element here. Say wrapper function executed before, or say original function will be passing through. It will get original function dot execute. So even we passed as an argument, we already know that that inside part is already, because they are local, the inside part, this is inside part, the wrapper function will called, then a display function is run. Okay. Now if that thing is clear, we can write the same things using our decorator. Okay, copy that part. Okay, as why I written that statement, that now you will understand. Okay, it is simply nothing but gives you a good messages. Okay, how the step by step the things will be happening there. Okay, now say after written our original function, that's why we are adding the decorator function. Okay, before our display function. So when we do that same thing, it looks more nicer. The code will be more simpler. Okay, we do not have to write those each and every line of codes. Okay, so now we can use this entire function as a decorator before our original function. So when the original function will be executing, then the whatever function is decorated inside the decorator function, it will be it was also executed at the same time. Means before it will execute it, then the display will be executed. Okay, so when the decorator will be added, the decorated part will be executed before, then after the original function will be executed. That's the main thing. So to write the decorator, you have to use some keyword like at the rate. It is nothing but defining any kind of like decorator or maybe a kind of getter setter properties in Python. Okay, so now we are using decorator to wrap up that function, that decorator function. Okay. Now when the display is executed, okay, the display is executed, then also the before the decorator function is also executed. Now as let's comment out all those things. Now write say display. If we execute that display, you will see lot of things written in our decorator. It will execute it first. Okay. So before when we execute a display, it will before comes in the decorator function as the same thing. It's nothing but this line, this display line is nothing but written as our decorator function backed on display. Okay, and something like this line, the decorative display, and then display exits. Okay, this thing now here the two line is written because even after we not execute, when we created that part, then as it's executed here, so before executing the display, it will first came here and that part is executed. Okay, the wrapper function, that's why it's written that wrapper function executed before wrapper function. Okay, then when we again that decorative display is representing the inside one, the wrapper function. Then the wrapper function will be executed our original function. Okay. So the same things we look more cleaner using simple word is display. Now, when the display function or original function is executed, automatically it comes here, execute, automatically it comes here, and first it will print, means it will first execute the decorator function. So the wrapper function will be returned. So wrapper function first executed, then this display argument will pass through. Okay. As we are sending this original function, then it will pass through, and this value is printed. The exact same things we did here, we did before, like log file, that file. The same things is happening here. Nothing but we create the code is much cleaner process, where using the decorator to execute the decorator function before executing the original function. So before like writing so many lines of code, we can simply use our decorator. Okay, and using the decorator, it will execute the decorator function before the wrapping function automatically written there. Then as well as the execution. Clear?
Yes, sir.
Okay. So same things like if I add other functionalities, suppose this is our display. Okay. These things we already did. Okay. Till now we did that part. Now, yeah.
So just tell me one thing. Whenever we are calling the display function, so
Hmm.
so is it calling the display function first or the decorator
No,
function
it
first?
will whenever the decorator they will be there, it will first call the decorator function. That's why I didn't. Uh, when we execute it, you can see this is the before we did the decorator things. When you call that our original decorator function, like the decorator this one, when you call that function using that argument, display argument, this exactly same thing is doing using this line, the decorator function. Now the line by line, like doing decorative display and passing through the display line. So it is representing our that time. Now if we execute that, now if we execute that, that's why first before as we are already using the decorator, if we not did not uh, hide that thing execute, then only the one part is written, because we are now added the decorator here. So where even we step by step like debug that and write those things of code, then when we call the decorative display, so display we are calling, what is it calling, we are calling before the decorator function is executed, then inside the decorator function, that original function will be there and it will be return the original function. So that's why I commented out all those things. And when we run the simple display, so when we execute that function, this function is simply nothing but goes the decoration function. Okay, it will starts to recreate. So decoration function not will be there. It will nothing but take the original function, the display function, and Before that, first it will try to execute whatever things it will be there. First, the wrapper function will be there. Okay, so that's why when we add the decorator, so if we debug the line by line step, you can see first this line by return wrapper function executed before the wrapper function, means this function is executed first, then it will return simply. Okay, first and then the original function will be returned. Okay, so whatever things you will be doing, the decorator function will be executing before. I'll give you one more example here. I'm adding one thing, so it will be much more easier. Okay, so point of view is the decorator function is executed before the original function is executed. Okay, that's why you will show the name like uh, here. If we execute it here, so that time automatically we are using that variable, that decorative display, to represent not only the decorator function, because as we are adding, this part is added because we are calling that time two times. Okay, one times we are calling using that like defining. Okay, that time the wrapper function is executed, and that's why it's written, because the wrapper function is executed and is printing that statement. And the next time it will, because that time original function is not executing. Okay, because adding the decorator function, I'm using saying that lines of words, because if we execute now, you can see that two lines of wrapper is written. So if we hide that statement, then it will not return the simple line of code here, because this decorator function we are calling using that original function displays pass through. These things will defined, and return is a wrapper function. Wrapper function will be now using that variable decorative display. The when we execute a decorative display, then original function will be executed and printing statement will be printed. So wrapper function is executed before display, and this is the statement. But let's experiment. Let's add the decorator part and printing using that statement. So when we printing using that statement and we call that display, sorry, or when we call that inner function, that wrapper function. Okay, so first this part is executed. Then when wrapper function is things, then the main function is working is our wrapper function first. So that's why first you will give the wrapper function executed before the wrapper function. Okay, then when it will return that original function, okay, it will not return the original function because original function is not defined yet. But when we call the decorative display in the next line, not the next line, because in that line it is happening in the same time. Okay, which I will say the next step. Then again the wrapper function is executed, and that current function it will be working is our display. Clear? So that's why it shows you that the wrapper function is executed before display. Clear? But this is debunking part, like step by step. If we like coach go into much deep level categories, so as I told you, don't go for that for now. You can go like already things is written in this module and you will see in videos. But if you simply use the logic of our higher order function and execute, then as we call that display function, it will nothing but goes to our original function, because that original function is our decorated up. Okay, so original function is returning a wrapper function. Then again, as our display function is calling out, because this is where nothing but calling our original function. So this thing is calling out. So this thing will represent the whatever things will be present here. Okay, inside that. So inside here, we are printing the statement and executing our original one. So that's why next time it displaying our that statement, that function here, and then executing a display function. Clear? you need to if it's for the first time you need to go through like by yourself you have to go through all of this, otherwise it's definitely hard like for you to do at a single time. If you guys have any problem in that particular understanding, then in the next session we'll again discuss about it. Okay. Now first let me finish that the decorator one. Okay. Now if we I'm not removing those lines, so it will help for you. Again, let's remove those part. Remove those part. Let's create another example. Okay. Create one other example. Suppose this is our original function. We may not need uh, let's keep it written here. Create another function, say called our suppose uh, some other printing statement, maybe some student name and age you need to print. Okay, so that time it's a good way. You will see even in some by default module that people whatever module they will be creating, they will simply use that arbitrary argument and keyword argument to creating the decorator function, then the main function. So whatever argument you will be passing through, it will might not show any error and simply execute it. So suppose let's create one info or some student info or any info. Like we already created one display function. Let's create another, say display info or name and age, the two argument maybe, and nothing but it will be creating in your function is display info dot format. This is display info. Another function is we have written. Now, as you can see, before we are not passing anything in our Apple function. Now we can write like if there is any argument is passed here, like name and argument age. If there is an argument passed here, we'll be returning means we'll be executing that function using that argument. So similarly, we had to add like the original function is there. Now we had to add some arguments, and as we are not passing any keyword argument, so it's optional. But as the standard way to write, maybe sometimes in future you have to create decorator. If you have to, if you became the software developer, you have to create the decorator, and that time it's not easy. You have to literally define each and everything before starting proceeding through it. So you have to create like almost like star argument and star star keyword argument. Yes. So you do not have to worry about whatever things it will be passing. You will not throw any error. It will simply go through it. Either it's an argument simple argument or it's a simply keyword argument. Okay. Now we'll be executing that original function using our argument and keyword argument. Okay. And here original function is written. This is typically represent here now or here, as this is not passing any argument, so don't worry, it will simply return our original function, as this part is optional. Now if we run display info, that time we are passing name and age. So name and age will be carried out using arbitrary argument, and this is simply executed, and this is simply executed. Okay, if we write display is running. Now if we write display info, it simply throws error. Yes, because we are not passing anything. Let's pass anything. Say John and 25. You can see displays info is running with our that function. Now, as if we wrapped up using the decorator, let's add that function as our decorator. Say decorator. Now decorator function, when you call display info, it first calls here this decorator function and pass this function as an argument. Now this will return the wrapper function. Now the wrapper function will be as it's written here. If the wrapper function is not nothing written here, then it will simply end as the inside function is written. So it will simply nothing but text to our text whatever argument will be passing, name and age, will printing one statement. So the wrapper function will be executed before that thing, the display info function, because it's not representing. Then the original function will be returning with that execution value. Execution value is our print statement. Okay, execute. You can see easy. The simple message is printed and our whatever functionality is there, it is executed. Okay, so this is nothing but the exact clear concept of our decorator. Okay, we can use decorator in our class also simply, but for now this is how the function is passed as an argument, and we can simply return as a function. This key concept is using our decorator. Okay, when we call one function, if the decorator is present, so decorator will execute it first, then our original function will be executed. Okay, same thing we can, as this is our decorator function, we can create one decorator class also. For that, we can simply write class decorator class. As we are currently learning the OOPS concept, but later you will understand that whenever we defining one class, because till now in the last sessions, that we are not written anything. Okay, but in future when you try to work by yourself, you will definitely wrote something that you're maybe inherit from another classes. Okay, in the next session we will do, but as it's our traditional way, you can write some argument like object. So for now it's nothing, because uh, if I told you that why object is become the green in color, okay, because the class we are defining, this class word and those thing is also nothing but one object from the object class it's defining in our Python. Okay. This is behind the back what is doing when we're creating one class. This class thing is nothing but a object that's the defining in our object class is presented in our Python. So when we wrote class decorator the object, there are some pre-properties. Okay, some maybe key methods and some kind of things. It inherit the properties inherit. Inheritance we will do in the next session, but for now, if we don't write object for now, it will not show through any error what I am trying to do. But as a good way of practice, if you declare one parent class, it's better if you write object and other things. So it may some indeed some kind of properties that it really helpful for maybe some work you are doing. Okay. So we are creating one the decorator class. So as there is something like you already know, we have to create some method. So when the class is maybe the object is created from that class, okay, maybe some function is called using that class. So or as we are creating the decorator as a class, so when the function is called, so the class is automatically created the objects from that class presented. So that's why we may had to use one special method that's called init method to initialize everything. So let's write init method, and it will nothing but returning whatever you returning, it will returning whatever function will be creating. If this function will be creating, then this is initialized whatever function we're trying to do. Say here, so original function is whatever function we are passing through. The original function we are passing through. Original function we are passing through, and the original function is here. So def, let's copy that entire thing.
Sir, you missed self.
Hmm?
You missed self inside in it.
I need it. I will write. So many calls and okay. So yeah, that init part now as the original function, because when we were calling that function, it will simply nothing but redirected to our class, and class is nothing but creating one object. So to represent our object, we definitely use one keyword, one argument. So self keyword. So self keyword is creating one object, or object we will be passing through, and within that we initialize our original function. Okay, from that part. So if we call like display info and pass this value, this is not decorator function. This is now our decorator class. Okay. We pass this value. It's called decorator class. Is not called because if we not write anything, okay, I find that here. So as we are defining that part, this is only initialized part, but if we need to call that, acha, the call properties also had to add. So def, this is also the special method to returning the function element. Okay. So when the original function is called, so that time the value will be returned. That's why we are adding this special method called underscore underscore call, and it's nothing but representing our self argument and the similar argument like arbitrary argument, whatever will be passing here. Okay. And now the same things, the original function, where in original function we have to write self dot original function. Similarly, now you can see now you can. So because when you call as this is a function, when you call that function in that class, here we are initializing that part, but there is not statement, so we can call that uh, enter function we already defined. So for that properties, we need to add one function is called call functionalities. This will helps to execute that original function here and return, because as we are adding the decorator properties, it is nothing but we try to executing this display info also, but there is nothing, no such thing, because as we written here, return original function with some element. Okay, returning in those things, return wrapper function, it is simplying the exact function, but we are not defining any calling element, that's why it gives that those error. So we had to add that part, the calling element, and then similar thing, we're reading the same. Okay, so here we added before we decorate is as it function as a decorator. Here we can as it class as a decorator. Okay, similar things we can even in real life we can again see that you create your like current working progress, some kind of things like creating the timestamp using this decorator properties. So be whatever working you are doing, if that doesn't matter, you can create one decorator. So the in between your working progress, you can calculate the timestamp that for your current work progress you are doing. But I am not going to write those kind of things because it's take much time, and for the basic part it will be hectic for all of you. So it's better I gives you one good example. I can show you. That's why I open that basic the date time module. This is called our date time module. It's important in many other part. I did not cover that part, but there is some basic decorator properties that we will be really using in our class one. Okay, so if we go there, you can see these things. I try to cover the class methods, class method. Okay, so whatever try to do is people are adding, those developer are adding some decorators. There's a class method. So get whatever value, timestamp value, or whatever data they will be passing through, the return value should be as a year, month, and date. Let's create the same things in our basic oops part. So we can go through, okay, what is class method and how those things are work. Okay. So till now, as this thing is completed, how the decorator part is working. So some kind of properties is bound to this class. So we can work through whatever written in this next one. Clear. Now here also one or two example that I am kindly skipping here. One is a logging example. That same things we did here in that example. in here that example. We can create one big example in our logging, but I am not doing it because it takes much time. Let's jump into our object part where we'll be directly creating using the previous example. Okay, so till now I guess everyone is clear. If you guys have any question, you can ask. Otherwise, we'll proceed to our oops part.
Sir, call method one more time.
Okay, call method is nothing but the same thing when we are doing using in our wrapper function with using the decorator. There is the as we with the logic this function is called. Okay, we need to call that function also na, when we are calling using this function. So when we call using this function, because it is simply function concept, automatically there is a logic written here, so it can call that function. Otherwise, it definitely shows some error. Similarly, when we create class as a decorator, when we execute that function, there will be some logic you should write. So the original function is should callable. Otherwise, there is some error. The error, if we show the error, the decorator class is object is not callable. See, so there is no function, no method we are defined so that we can call that function. So that's
So
why
basically, the call method is doing the wrapper function thing.
yes, is basically doing the wrapper function thing. Nothing but take the function as an argument and call that one. So gives you the desired result. Okay.
Hmm.
Even it take time, I know, because it's a key concept. Is the advanced part. You have time in home. You can just go through. Like you do not have to go other side. The same example you can proceed through. So it will give that idea. Then you can create one like after finishing the oops concept, you can start solving out the basic questions in each part, like basic coding paper. After finishing that complete oops concept, that time you will understand. Okay, it will take time because oops is a vast subject. Okay, so from that last session, mm, let me copy. Okay, these things we already did, the class variable and all. Now for today, we will start covering the class method and the static method. Class method is nothing but the same things we created. This one is created as our object method, so it's work as our object. The same thing if we want to create one class method. Okay, so for creating class method, we need to use one decorator that's called class method. If we attach that decorator inside that method, so it will in general define you as your class method. So suppose if we create one say raise amount, this variable, we create one method with that variable also, like raise our amount if that any raising amount, raising percentage is there or not. Okay, so when raising one certain percentage, create div and say our create set raise amount. Okay, we are passing the amount we'll be raising there, and then raise amount is equal to our amount. Now, as this method is not our objects method, okay, for the object what we did, we written here self. So self is represented the object there. Okay, whatever object we are creating, by using the self keyword, it will nothing but represent each and everything from that object. But we are creating one class method, so by convention, it's good way to write CLS to represent that class. You can write other keyword also, because it's nothing but work as your argument to represent that entire class. So by convention, it's a good way to write class, and you should follow in that way also, like self for representing object, class CLS for representing class, and then returning our raise amount. This is our, let's change. um, this is our raise amount. We are changing that variable, that class variable. So let's write CLS dot raise amount. So we are changing that variable to whatever amount we are passing here. Okay. Now, as this is our class method, so for that's why you should write here at the rate simple nothing but class method. Now this method is represented as a class method. Okay. Simple, because these things, the class method, whatever the function is written, it's already written behind our back. Okay. If you want to dig through, you have to go through the following documentation, then debug, dig into much deeper and all those kind of things. If you wish, you can go through it. The Python documentation are there, but you do not have to, because in daily life it may not be necessary. Okay, if you write same, but the understanding of these things, like leading and decorator, is really important. Sometimes you have to create manual decorator for maybe some class you create, or maybe some function you created. That's why those concept I covered, and in general or in your daily life, those part will be really needed for you. But debugging these things, digging these things may not be much required. Okay, but if you want to go through, then you can follow. But simply if you write the class method, it will nothing but represented our entire class. Okay. Now this is execute. No error is there. Now create, say, employee dot raise amount dot raise amount. Okay, the same value. Why? You may ask that we are not passing any value in the amount here. So what is happening here? For now, we are not changing any values for that class. So it will simply nothing but take the default class variable we are representing here, the raise amount. So that value is printed. Now, if we change, like, say, employee dot our class variable, like this is our class variable, and class variable takes one argument like amount. Let's give it one amount, say 1.5, 50% hike, or the same things like in the previous day. If we came here in the previous day, how we change the class variable using the employee dot our raise amount equal to some value, say 1.5. For now, we are doing here like using that class method to change that value. Okay, so employee dot our set raise amount and some value, because the amount is needed to change the new amount. So it will initialize our class variable to the new value, and it will set it here. Now execute again, print this thing, you will see the value is changed. Okay, simple. Similarly, nothing much. The we did using as a class, as the class is also accessible because classes first tries to find out if there is object is present or not. It can also accessible each and every method and the variable using that object. So we can change that value using one object also. So we can write simply mp1 dot set raise amount to some value, say like 1.06. Now if we print, you will see it will change all the value, because previously when we try to change that time last day, that time only for that only object we are using, because for that object we get using the dict method, you can see that the raise amount parameter is created. But now when as it's a class method, when this value is once initialized or maybe changed, maybe modified, this is changed for all that object we created. Okay, because the entire class variable is changed. So that's why for that you can see we only change that using one object value, we can change all that object value. So always be concerned when you use the class method. Definitely you have some purpose to do, like creating any method that only you had to modify or maybe some changes using the class only. If we change that part using that the object, then the for the whole object value, the object the entire variable or the function is changed. That's why the simple the object methods are there, and for the class method simply nothing but we will be working using the some modification needed in our classes. Okay. It's nothing, it's simple. If we understand the last session, then this is nothing much goes beyond. Now, uh, as I told you, that's one real life example. You can see, say, using that class method from the timestamp, whatever data they will be providing, they want to get the data in form of year, month, and date. Okay, day. So, say, suppose we create whatever garbage type of value we'll be receiving, we can simply parse that value, or maybe parse that entire string, what is the thing, and get one means clean that part to receive the value using the first name, last name, and some pay value. Then initialize that thing. We can simply use one class method for it. That's a real life example. Okay, as I showed you here, you can see from today is one method that present in the timestamp. It's nothing but simply returns you the current timestamp. So as it's when you create the today, it definitely returns you the current timestamp from where you are living. Okay. If this only affect one object, means the current one or maybe the current class, then it will much bother, because you will simply return as is desired. If it bothered each and everything, maybe if you likely to return something like timestamp from today, and some people from other continent return the timestamp, then the desired value may not be the same as they wish for. Okay, so that's why they people using the class method. So as the each time, it definitely depends upon which geographical location and which exactly time you are presenting. Okay, those are the means, real life example of using the class methods. Okay, so let's get the same kind of logic where we'll be simply written here whatever the each like minute, second, weekday, J day, DST, whatever the timestamp they'll be providing, but will be simply had the return of year, month, and date. Here also you can simply return as your first name, last name, and email. Okay, copy that thing, return. Okay. Now suppose we are having like score one. Okay. Now okay. Now let's similarly create one class method like parse our string, and string CLS and our say employee string. What it will do is first we need to parse that keywords for the first name, last name, and the employee salary. And we are parsing using, you can do, we can simply use split method in our string to split based on that value dash. So for our first name, last name, and pay, you can simply write emp string dot split and dash pay. Let's see once again, first name, last name, pay. It will take from and split means it will create one either tuple or list, and we are unpack that using that keyword. Then we initialize to our class, set return CLS our first name, last name, and pay. So it will came here. Let's change it. First name. Yeah, in the last session, I told you that those things people written as the same name. You can see that reason. Now there should not be any error. Yes. Now let's debunk it. Say create one employee, employee one. Okay. How can create? We can create from employee our class. Okay. Our method and pass our first employee value, employee string one created. Now print. Let's check mp1 dot email. You can see this is like kind of real life example. One of the best thing how we can use the class method. Sometimes the data may not be you get may not be desired. You have to prepare it like before creating object. Maybe some functionalities you had to do that time. You definitely use class method. So it only modified the class only. Okay. Then after the creating that object, maybe in your any kind of object, then it will may not bother to your class. Okay. And similar like class method, it will take only 5 or 10 minutes more. Okay, before I finishing the class method, there is one method is written, one that is called the static method. Static method is nothing but sometime
Sir,
in your
so
logic, yes,
sir, so a part string method. So what is actually returning?
I can't hear you. Can you repeat it?
I'm saying so second class method.
Mhm.
So what it is actually returning?
In
An
that
object.
second class method, no, it's returning to our class. This our class is returning to our class the name, the first name, last name, and pay.
Yeah.
So whatever these things is created, this thing is it will be uh, means say the argument is passing is our first name, last name, and pay. Now suppose this is our logic. Whatever things it will be passed through in our employee class, it will nothing but parse that things. So it's a using this dash and created first name, last name, and pay. Now, sometimes this kind of data you will be receiving, okay, in the string format. Sometimes some address and email ID is receiving like in this that format. But you have to initialize your class so that if you create one object, where you will be creating one object from that class using some value. So from that class, we will be creating that class method and parse that element to create one object, that is employee one. Okay, as the employee one, you can do this thing, this entire thing outside of your class also. You can create one function, but this is not suitable for if you create one module. So when you try to import one module, then those things will not be imported out. So that time you definitely create one class method. So class method is nothing but some functionalities they will do when if some functionalities you needed to define your data, maybe for your purpose, I don't know, but maybe some functions you need to do before creating one object. That time we are creating one class method. Okay, so this class method is nothing but creating objects by parsing the entire string based on this method, like the dash method, and provides you first name, last name, and pay. And from that first name, last name, and pay, you create one object, that's employee one. Okay, so your object is created.
So sir, basically it's returning an object.
Basically, we are creating one object based on the properties, based on the class method, and some data we provide, or maybe say some string we provide. We are creating one object.
Yeah.
Class did not return anything. Class always like create something. Okay. Object methods always return when we are like creating some functionalities. Return in sense for
No, no,
object we,
you wrote return. That's why I said.
yeah, no, no, obviously you had to return. Na? If you
Yeah,
did
yeah,
not return, that time what you had to do is you can simply write cls dot first name equal to first, cls dot last name equal to last, but it may not create it. It definitely affect everything, na? Because you will see the same things we did in the employee when we did the class dot method. So it will affect the entire class. But here we are simply nothing but returning in that class our first, second, and pay method. That's why it return in our class because this CLS represent our class. Okay. So it's nothing but, as I told you last day, we can create one object based on your object name as well as employee name. So this line, na, return, this line is nothing but written as our employee, then bracket our first name means here Andrew, then Jones, and then this scale. Okay, this part is returning to, you will see this is returning means what it will create. You will nothing but creating one object. When we create last day employee one equal to, if we do that, so nothing but create one object, correct?
yeah.
Yes. This is like live example, like what in when you need to do using when you need to use class method. Okay. Similarly, like the class method, there is another kind of method. It's called static method. Static methods you will need when there is no relation in between object and class, but some functionalities you had to do. Okay. Sometimes may say, let's say this is our employee class. Okay. Now if we had to create one functionalities where we want to check whether this input date is a weekday or not. Okay, so if this are nothing relevant to the current things you are working like employee, maybe some another things HR will need to do and they want to check whether today is or some date is weekdays or not, then it will return as a true or false, and based on this maybe he had other thing to do. So when none of these things are relevant but you still need one functionalities, then you can create one static method. Okay, like the same example I did, we can check using whether it's a weekday or not using the static method, and it will definitely not reflect either its class or object, but it's always situated inside a class. So they, you will know the purpose of using, because class is nothing represent the whole things in once. So maybe some methodology you need where the class and object may not require, but for your other purposes you had to require it. Okay, maybe you are in that example some things like checking holiday list based on this if some days is weekday or not. Okay, you this one functionalities which is nothing related to our objects or classes. Okay. So for that time let's create one static method, and similarly for our class we can simply write static method, then dev we are checking is it's an weekday or not. Mostly we want to return if this is not an non-holiday. So for better you write, and some date it will require. You will see that I am not writing anything like CLS or cell because it's not relevant. Okay. For the static method, you do not have to, this is simply nothing but work as your function. It's nothing related to your object or class. Now let's write if date dot weekday. I'm writing weekday because I'm not importing here anything. We'll import some basic date time module, and there is one function called weekday. It will check whether the weekday is, if it's a weekday satisfied, then return true, otherwise return false. Sometimes some argument the weekday may be represented 5 or 6, in somewhere it represents 6 or 7. Okay. So it has some argument, some parameter that helps you to decide whether you need to choose it is 5 or 6 or 6 or 7. I am not going through that because those, I had that module. If you guys need it, I will send it. Go through it. It's easy. Now, for by default, it will check as your 5 and 6 as your Saturday and Sunday. Okay. So that's why I'm reading date dot weekday as 5 and date dot weekday if uh, if 6, then you can return something like this is not a weekday, false, otherwise return true. Now let's import error, because import module always should be top of that. So import date time, no error. Now you can write like some date 1 is equal to, let's suppose date time dot date. This module, if we pass through date time dot date, it will require 3 elements: date, month, and year, and we will simply return back your date. Okay. Say suppose it's an 2020 and it's in July, say 26. Okay, that date. Then let's check print employee class dot method is workday and pass our date one. Okay. If it's a weekday workday, then it will return true, otherwise it will return false. Execute. You can see it's written as a false because it's definitely comes under your weekday. If change the date, suppose say 31, and execute, you'll see the return value is a true. So whenever you will need uh, one kind of functionalities, when there is no logic regarding to our class and object is used, okay, we may not to hinder anything, that time it's better to use a static method, so it can work alone and work defaultly each and every part in our entire program. Okay, that time we are using static methods. Okay, so that's all about today. Okay, if you guys have any question.
Sir,
Hmm.
can we say that the static method works like a normal function?
You can tell like that, that static is nothing but you work as a normal function.
Normal function.
Okay, but because I never suggest, why, because similarly when you will work like, if you call as a simple singular function, but you have to work like calling through your class, like we did employee dot that function or some that method. That's why it work as a, you could say the working principle as your normal function, because you may not require any class and objects, but definitely you have to work through using your class. Okay. Yeah, definitely you can call it as your work function. Because when you try to create a module in your real life, sometimes you have, if you as a programmer in your daily life, you have to daily basis you have to work through your oops. So when you work on your oops and those modules, that time import that module. Say I want to import that employee module, so each and every functionality is imported. Okay, so that's why those kind of things also written inside our one class, not only a function. Okay, so that's all. Let's go through this.